We already checked 2 and 4 and 12. The one that's missing for those of you guys that did the other assignment is number 82. Wait, why is that so easy? You might have done this one different ways with work, but long story short, you had a magnitude. Long story short, you could have done the horizontal and vertical. They didn't show all the work. I would have done something like, it was force times distance, right? And I think they said force was vector V.
Yeah.
Yes, you guys putting vector arrows still? Don't want me to take off city points on the test? Vector V. Do you guys remember if you have magnitude and direction, how to make components out of it? Yeah, I do the cosine and sine things. We would do magnitude times cosine of angle. Your mouse is not very happy today. And then magnitude times sine of angle. That's how you could have gotten the components for the force, because they gave you the magnitude and they gave you the angle. Just go with me, I know it's not the prettiest thing ever. Distance, they told you it went how far? 100. And if it's 100 in one direction, meaning not diagonal but horizontally, then we're going 100 horizontally. And we're not going any vertically. So if you guys were trying to follow our formulas, this is how you would have set up each of the vectors in components. And then work says force times distance. Dot product would say first times first, right? Plus second times second. But question, what's this multiplication going to be?
0.
0, which is why they just had first times first as their work. Do you see it? Final answer, 21,650.64 foot-pounds. Foot-pounds. That's a work measurement. But once again, we're not in physics, so let's just put little parentheses. Don't stress too much about that. Hey, kiddos, if I were you, I would highlight number 82. Oh, you know, just saying. Something like it, maybe. I would highlight number 82. Just saying. All right.
It's going to be on a thing that
Yes, it's also in the video if you want to check it out tonight. Okay. Section 6.5.
Oh.
Wait a minute. Where are the evens of 6.5? There aren't any.
Wait, what?
There aren't any. Weren't they only odds?
Oh.
Oh, so instead of us going over the even answers, which we don't need to, maybe I gave you the odds on purpose. We're going to go over questions that you had on the odds. But first, did we get to do an example at the very end of class with the roots? Not really. Kiddos that worked on homework, were any of these homework problems the roots of a complex number? Not the power, but the roots. Any roots up here? Well, we finished the example. None of them were roots? Oh. Okay, well, maybe that's a sign that maybe they're not on the test. I don't know, I said maybe. I'll give you more specifics. Maybe later. So none of them were roots. Okay, do you guys have, I'm going to go ahead and pull up the book. Well, let me wait till now. I'll pull it up.
Are you recording?
Yes, I am. I'm pulling up the book. Do you guys have any questions on the odds then? If there were no roots, then we don't need to look at roots first. Ashley?
41.
41. What else? Nathan? What else? 41, 79?
19.
19? Anything else? 35? Anything else? One more. Alright, I'm asking. Let's go ahead and go get our section. I'm just drawing dots on things, aren't I? Okay. Let's see if the book actually works today. E for effort. It doesn't. Speak positive thoughts. Uh-oh. It's not even showing like all the table of contents. Maybe it's a good sign. It's getting ready.
Oh, it's
Or-
kind of flat.
Starting to, yeah, it does. Kind of. Our book is also kind of tall. Well, oh, there we go. C for effort. Scroll down. Scroll down. Now.
It'll do it. Okay.
Huh?
We're getting there.
Huh?
E for progress.
Okay, while we wait, do you guys want to write down a test for me?
Sure.
Alright, let's do that. Let's be productive while we wait for the silly book. Well, I mean, you technically always have a choice. But you don't have a choice to get 100 on your homework spiral, which that's for you, and not do it. That's not a choice.
What if we write out all the questions and then say, I give up on all of them?
Then I'll put a smiley and then I'll probably a 0.
Just wait, Tyler, just wait 3 minutes.
No.
Okay, hold on. It's supposed to be 3 minutes of productive work, and even that was failing.
We're not allowed to stare at the
45
paper.
minutes of productive work.
Caleb,
That's-
retire that joke.
We're not allowed to just stare at the paper and wait 2 minutes until you go on.
I think that's even below the American average.
But I may have been doing
Caleb is below me. I'm sorry.
I do not support orange. Okay.
Oh no, was that on recording?
Somebody
I
said
played
that to
ball this
Tyler.
morning. You should totally go check it out.
Where's the YouTube channel?
I'll send it to her. I have her number.
Different number.
81,
Wait, you actually?
Yeah.
Or you do because Nathan probably called?
Yeah, according to God, that's what phone.
Alright, sorry, still thinking, it's back, it's back. It's still thinking.
That's our home.
Yeah. I have churches. I bring
45, 45.
Alright, homework questions, I'm setting up on my iPad.
Whoa.
How about now?
No! There's one more like that.
Remember when I said
Good sign. One more to write down, 95.
95.
Alright, you got it? Let me go back and see the questions. Oh, I erased them all. That's not helpful.
Oh.
79,
71.
35, 71.
I have 19. 19, 35, 41, 71, 79.
Got it, thank you. Alright, let's start with number 19. I actually have it showing right now. We'll get it while it's still showing. How about that? Unless.
Let's do the table of elements before I use forms.
Alright, number 19 gives the following. Represent the complex number graphically, then write the trig form of the number. Why was number 19? Oh, actually, he was fairly normal. I thought number 21 would be harder, but maybe I didn't give him to you. Number 19, I have an A and I have a B, right? Okay, so I have negative 7 plus 4i. Well, that's not what I wanted. I apologize. This one.
Let's have a table of
Hey guys, how do you represent this graphically? What do you do? Yeah, right? Because the real component is the x, the imaginary component is the y. So I'm going to go negative 7, 1, 2, 3, 4, 5, 6, 7 on the x. I'm going to go 1 and 2 and 3 and 4 on the y, and I have my represent graphically. Good. But now I need the trig form. This is actually a great question for tomorrow's test. I would have everyone tune in. I tuned out. We need to find a trig form, and the trig form says, no big deal, there are formulas. To find r, we take the square root of who? Square the first one, negative times a negative is a positive, and square the second one. We end up with, right? 5 goes in awkwardly 13 times, we're just going to stop there. R, done. But who else do we need for our trig form? The theta. And we have a formula for that, right? Use tangent inverse of B.
over A.
Mhm. Somebody from last night. Let's do degrees for sake of clarification or simplicity of visualizing. What would be tangent inverse of 4 over negative 7 in degrees? I think it's negative. Or the decimal 754? Uh-oh, who sees a problem? I see a problem. Where is that angle? Isn't that,
You gotta do that classic 360 degrees.
yeah, because we got the wrong angle. Cameron's saying like, hey, it's not supposed to be there, but we know what to do to get to the right one. Kiddos, how do we get from that angle to the right one? Let's add 180. We can use tangent inverse. We can use tangent inverse. If you guys don't like the equals because it's not really, that's okay. Just put little colons and say we'll get back to it. To find theta, we say, okay, plus 180. Now, if you're in radians, which I think the back of the book was, it was weird, like little decimals, point something, something, something. You wouldn't add 180. What would you add? You would add not too much.
Pi.
Pi. You would add pi. 1 cows up, right? In degrees, you would end up with 160. No, not 160, 150, right? Struggle. 0.266?
No, 2.
No, 256, right? Struggle. Mental math is not working for me today. Dun, 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 dun. Wait, no! Those are the pieces. How do we make the form? What's the trig form of a complex number?
R times open cosine theta plus sine phi sine close brackets.
Good. I goes first just to make things look nicer. I'm putting degree marks everywhere for some reason. Dun, 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 dun.
No, no one said
Hey, you party pooper. Get out of the class.
I do not know what that is. Okay, so we still have more questions, right? Number next one was number, I don't know, I have to go find it. 35. Is he actually on the page? Are we in month? Oh. Hey, all the pages are working today. Number 35, wait, don't we have the trig form? What do they want us to find? Standard form. So wait. You guys remember yesterday? I'm not going to do this entire problem. Let's just go back to our notes real fast and say, wait, what did we do in our notes, which is where you're supposed to be looking. What did we do in our notes when we had, where is he? Here we go. Nope. Back one more. When we had a trig form and we wanted to go to standard form.
You distributed it.
Yeah. Step number 1, we distributed, just in order.
You did the
And then we did the math of solving. Now, how do we do 135?
It's 45.
It's in the unit circle. It's a 45 degree in the second quadrant. Now let's go look at number, which you guys were a little stuck on. 35. Oh wait, isn't that the exact same angle? 3 pi over 4? 3 pi over 4 is the 45 degree in the second quadrant, so we're going to make cosine negative root 2 over 2. We're going to make sine positive root 2 over 2. And we're going to multiply in 9/4. That should match up. And how do we graph him? Well, kiddos, can't we just graph our 3 pi over 4 angle? And then can't we draw something representative of 9/4 and say dun 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 dun? That's what I would do. Alright, that was number 35. Let's go to the next one. I think it was 41, right? Good. Number 41, I see he's over on the other side of, that's the eraser. Other side of the screen. Writing a complex number, what do we got? Oh my goodness, look, it's the same thing, but wait, is pi over 9 in the unit circle? No, we're not using the unit circle for this puppy. What are we going to do?
Calculator.
Plug it into your calculator. Literally do the distribution, but literally plug in 5 times cosine of pi over 9 and plug in 5 times sine of pi over 9. But what do you have to make sure your calculator is in to make this appropriate? Radians, yeah. You have to make sure your calculator goes into radian mode because these angles are obviously in radians, right? So plug into your calculator, go mode, go down, instead of degree, make sure it's radian, that's selected. And you literally type in 5 cosine pi over 9, that will be your A, the nasty decimal. Plus 5 times sine of pi over 9, that yucky decimal, times I will be your B. Then you guys had a question on number 71 and 79. Alright, last one, so keep on the next page. Make sure you're in radian mode. Because of those angles, they didn't have a degree mark. So they're telling us it's not degrees, and even more specifically, they're trying to help us remember their radians since there was a time.
Can we just convert?
Okay, number 71 and 79. Oh my goodness, I gave you guys both just power ones, huh? All you have to use is de Moivre's, kiddos. So let's go ahead and instead of me solving both of these, let's just go peek real fast at what's going on in our notes for de Moivre's yesterday. The last thing we covered. How did de Moivre's work? Doesn't this example look suspiciously like 71 and 79, or maybe it's not that suspicious after all? I see the fourth power. And I see somebody raised to the fourth power. And what does the formula tell us to do when raising someone to the fourth power? Check it out. If this is z, and that's a fourth, I'm finding z to the fourth. Okay, sorry. So go ahead. Yeah, the number on the outside does the exact same thing as what's being shown. So 3 is going to be raised to the fourth. Then you write your trig form, but instead of using the old angle, you use the formula that says whatever power that is, raise the r to the power and multiply the theta by the power. So the power over here was 4, which is why not only did 3 go to the fourth power, but also the thetas got multiplied by 4. That is what our formula shows us. You see it? So I'm not going to solve both, so let's just pick one. Let's do 79 because he was the last one. I think some of you guys just were like, I think he's hard, let's do him. Or you got stuck a little bit on the formula. 79 gave you what function? 3, 15, and then to the 4th. Okay, so 3 is the r, 15 degrees is the theta. It's already written in trig form, being raised to the fourth power. They weren't even creative and change it. That's all right. So then, kiddos, how do I find this complex number, which I have to the fourth power? What's de Moivre's? Oh, that's not fourth. That's 3. How do I do it? 3 is raised to the fourth. It's just a number. No big deal.
Multiply 3 by 15.
Careful, 4 by 15. But yeah, you're right. Take 15 degrees and say, hey, I need the power times 15 degrees. Sine of the power times 15 degrees. 3 to the fourth we talked about yesterday is 81. 4 times 15 is 60 degrees. Plus I sine of 60 degrees. Now that's trig form, but we gotta check out the directions to see, do they want us to go to standard form? Write the result in standard form. So we're not totally done, but we have all the information that we need. To go to standard form, we do what some of you guys were asking, and we just distribute. Wait, do we have to plug that into our calculator? No, because cosine of 60 degrees, we should know. Cosine of 60 is 1/2, sine of 60 is root 3 over 2. So we can plug that in when we multiply. And we end up with our final answers of 81 over 2 plus 81 root 3 over 2 pi. Dun, 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 dun. Dun, dun. Okay, with all of that, kiddos, I know you had a lot of questions on that homework. The crazy thing is, though, there were examples in the notes that went directly along with those. So please make sure when you're doing your homework that you have those notes nearby, not to make fun of any of those questions. Thank you for asking them. However, maybe you could have gotten more than you thought you could have when you were initially doing the homework. All right, with that, kiddos, there were no homework questions on the nth roots, so let's go ahead and just for sake of time with the test tomorrow, let's not worry about them. I might peek at it just really quickly on Monday after the test, but we don't need it for tomorrow, okay? Now, does that mean you won't need de Moivre's? No, you need him. You need any of the formulas in 6.5 or 6.4, and I can keep on going back 6.3. The more formulas you write down, the less likelihood there is of you guys missing some of the ones you need on your test. With that, let's go ahead and go back. Oh, I just closed it, didn't I? to the homework review, no, sorry, the test review. Let me open him back up just one more time real quick for anybody who needs him. There we go. Let me scroll down. If you guys don't have your book or your calculator, if I were you, I would run to your locker. If you don't have a book or calculator, I'd run to your locker, grab a book and or your calculator real fast. I do have a few extras up there, but not very many. I think some have already been taken. They didn't bring their books or calculators.
Oh, that's impressive.
I know, right? Fine.
I may not do the homework after.
Remember stuff tomorrow, kiddos, or else you get in trouble. Like last time.
Oh, yeah.
I'm screen ready for honors, so I think your guys is finally pulled up. If anybody still needs to write down the test review, it'll be up there for a couple more seconds. I'm going to actually pull up the test review itself, and I might have you star a few particular problems, unless I think they're all good. That'll be fun. I might have you star a few particular problems, as far as what to study tonight. Not just practice, but study tonight.
Do you think
Can you go to the front table and grab me? I'm gonna wait till everybody gets back in here to give a couple more announcements before just giving you guys time to work. Filling session. Remember, test review. Ricky is trying to remind you guys back there. No directions and no grading is required. The rest for your homework spiral grade, even if you're absent a day or you didn't have the homework quite done on time, make sure you get that grading done with the videos. Notes, if I were you, why not just update your table of contents real quick right now and not be stressed tomorrow? Double check your table of contents right now, guys, and have it all ready to go tomorrow. Yeah. For your formula card and the half sheet, whatever you're using for your formulas, you can write stuff back. I don't mind.
So can we just write top, bottom, and
No,
not on the
run it at different sides and cover sheet. If you guys want the breakdown of your test review, I think pretty much all the way up to number 41
just law of time?
is law of sines, law of cosines, Kieran's formula, and the area formula from 6-1. Those are the formulas you have to have memorized. You want to study for tomorrow? Yes, I will be checking your formula cards. Okay? So all the ones up to 41, these are all solving triangles, law of sines, law of cosines, area, etc. Okay? Then after this are all the vectory ones from 6-3 to 6-5. Sorry, vector and complex number ones.
Would you check our formula cards and we like to write down the formulas? So we can get them out of the
If I were you, I would just say if you're stapling the formula cards, you're allowed to write down 6-1, 6-2 formulas on your cover sheet once the test review.
That's one, yeah.
But don't write them on your formula card, I would say write them on your cover sheet.
Sweet.
Or on your test. Oh, let me get the next graphic one.
we still need to record?
Alright, pause. Eyes really quickly. These ones right here up to 41 is 6.1 and 6.2, okay? 6.1, I'll just say and 2. You guys know what I mean, right? 6.1, 6.2. The last ones down here are 6.3 and 6.4. Now, for sake of time, because law of sines, law of cosines, and vectors take a lot of time, I did not give you review problems on 6.5. Now, does that mean the test is not on 6.5? No. But what that does mean is you just did a homework on 6.5. We went over questions on 6.5, and you're allowed to write down the formulas from 6.5. So that should be what's freshest in your mind. So one more time. I picked out good problems of 6.1, 6.2, law of sines, law of cosines, area, formulas you need to memorize. Then I picked out particular problems from vectors, the ones I thought were most important from vectors. The one thing missing might be work, but I told you guys to highlight number 82 from section 6.4. And then I did not give you review problems from 6.5. You could work on more problems past number 95 to review 6.5, or you could review your 6.5 homework and notes, okay? Besides that, I think, for the most part, the review is a good indication of tomorrow, besides missing 6.5. And then let me remind you really quickly before I just say work till the end of class, and literally that's where we're at, okay? I told you guys to study work, right? Like number 82 from 6.4. I told you guys back when we were there, let me just go there quickly in our notes. And if you want to highlight in your notes, this is a good idea. Didn't we do 3 types of word problems with vectors?
Yeah.
We did the one where we had multiple things working together on a single object. We got in component form, we added them, set up equations, and solved. We had the problem where we had an inclined plane. This is from 6.3. And I told you one of these types would be on the test. This one, the math was easier, but you had to know the triangle to solve. You had to know the triangle to solve, which means you have to study these word problems, kiddos. One of them, one that is very similar to the ones you did in class, is on the test. And then we had this whole jet, wind, add them together, component forms, find the magnitude and direction of the resultant. Those are the 3 types of main word problems in 6.3. One of those types will be on the test. I gave you a hint about work. That's the second word problem on the test. And the third, they might not be in this order, but the third is something to do with law of sines, cosines, solving a triangle. Okay?
No.
There might be a bonus, so maybe there are really 2 types of word problems, but one of them is a bonus. But either way, the word problems will come from these 3, or work, and work, I should say. And then solving the triangle. Kiddos, the rest of class, I think I've given you a lot of hints. Make sure you bring your calculator and your formula card. I am chilling if you guys want to ask me anything. Otherwise, let's just keep working our test review. And we're good to go. I'm going to stop the recording.